Let's look at the molecular geometry for CO3 2-. We can see there are three oxygen atoms, bonded to that central carbon. And according to valence shell electron pair repulsion theory, those three oxygen atoms are going to spread out as far away from each other as possible. That should give us a trigonal planar molecular geometry. We can also use the AXN notation to make sure we have the correct molecular geometry for CO3 2-. A, that's the carbon, and then X, that's the number of atoms bonded to the carbon. There are three oxygens, so we'll put a 3 there. And N, that's the number of non-bonding electron pairs. All of the electron pairs are involved in chemical bonds between the carbons and the oxygens, so we can just ignore N. So you could have memorized that AX3 is a trigonal planar molecular geometry. Or if you had a table available, you could look it up. As we go down the table, we see AX2, and right below it, that's AX3, which is trigonal planar with bond angles of 120 degrees. We could also look at the three-dimensional structure to confirm that and see what a trigonal planar molecule looks like. So we have a carbon in the center, and then we have the oxygens out here. And you can see they're spread out as far away from each other as they can be, and they are in a plane. We can also see that the bond angle right here, or right here is 120 degrees. So that's the molecular geometry for CO3 2-. This is Dr. B, and thanks for watching.